Alright, so for number 1, it tells us that the graph of the derivative of f. So you need to be careful and make sure you understand what's graphed over here. So it should always be labeled, or at least explained in the graph, or in the problem. So we have the graph of the derivative of f of x. Which of the following must be true about the graph at x equals 3? Alright, so at x equals 3, looks like our y value is 2. So let's look at what we're talking about here. Our derivative of f of 3 is 2. Right? The derivative of f of 3 is 2. That means the derivative is positive. So what does that tell us? If the derivative is positive, what do we know about the original function? Well, wrong type of derivative. That would be if the second derivative was positive, right? We're talking about the first derivative here. First derivative is positive, then f is increasing. Right? So if the first derivative of f is positive, then f is increasing. Right? The derivative is the slope, or the rate of change. So if it's positive, that means we have a positive slope or rate of change. It's increasing. The original function is increasing. So knowing that, a and b can be crossed off our list, right? Those both say that it's decreasing. So we know it's got to be increasing. So we're left with 3 options here. Well, we don't know that f is going to be positive. We don't know that like the y value on the original function is going to be positive. There's nothing here that's going to be able to tell us that. So we're going to cross that one off also. What we need to figure out is, now, is f going to be concave up or concave down? How do we know whether a function is concave up or concave down? Second derivative has to be positive or negative, depending on which one we're talking about, right? So concavity comes from the second derivative. So you'll see these problems, there's not a lot of work, there's just a lot of thinking, kind of thinking them through. So second derivative, we want to see, is the second derivative positive or negative? So at this point right here, what do you think? How do we figure that out? How do we know if the second derivative is positive or negative? Well, that's the first derivative part, right? Because this is the graph of the first derivative. Since it's like above 0, that means the first derivative is positive. If we're below 0, the first derivative is negative. But now we're kind of transferring, or like kind of changing gears and looking at, okay, second derivative from this graph. What's that? It's the slope, right? If we look at the slope of this line, that is the second derivative at x equals 3. Right? Is that slope positive or negative? Negative. Right? So the second derivative is negative. We don't need to know exactly what it is. We just need to know whether it's positive or negative. Right? The slope of this graph would mean the derivative of this graph. That's the second derivative. So here the second derivative is negative. So which one is it? Concave up or concave down? Concave down. Right? Second derivative is negative. F is going to be concave down.